So alkanes. Alkanes are the carbon structures that only contain single bonds. So to name them, find the longest continuous carbon chain. Now, sometimes the longest continuous carbon chain actually bends, so put your finger on the carbons as you move through it to actually find the longest continuous carbon chain. This name becomes the root. So, once you find the longest continuous carbon chain, use the table, the root table, to figure out the root part of the name, and then the suffix is ane for alkane. For alkanes. So if we have 3 carbons in a row, we can see that each carbon has a single bond, so it is an alkane. So using our root table, we know that 3 carbons is prop, and you add ane, and the C3H8 is called propane. If it had 4 carbons, it would be called butane. But for 4 carbons, ane because it's an alkane. All right. Sometimes they'll have side groups on them because of branching. Take this compound. If you look at this compound, I haven't put all the H's on just to keep it simplified. If you look at this carbon, if you follow this carbon chain, there's 3 carbons. If you follow this carbon chain, there's 4 carbons. So the root for this is but, and it's an alkane because they're all single bonds, so the suffix is ane. So that takes care of this portion. Now we've got to deal with the side group, which is right here. So you identify how long it is. It's only 1 carbon chain, so you go back to the root table. 1 carbon means meth. And what you do with your side groups is you have the root and you add YL to it. So your side groups will all end in YL. So now we've identified the name of our side group, you have to indicate which carbon it's attached to. To do this, you need a numbering system. So if I start counting my longest carbon chain, start here, 1, 2, 3, 4. If I went the other way, it would be 1, 2, 3, 4. Now it does matter which end you start numbering from. You want, when you name a compound, you've got to have the lowest number combination possible. So if you look at these 2 numbers, 2 and 3, 2 is lower, so this structure would be called 2-methyl butane. So this tells me that the longest carbon chain is 4, single bonds, so it's an alkane. And on the second carbon, there's a methyl group. There's one carbon with 3 hydrogens attached to it. Okay, now what to do if there's 2 different types of side groups. So if we look at this carbon chain, we've got to first identify what's our longest carbon chain. If we follow this, it's 3. If we follow this, it's 6. This would be 4. And this would be 6. So we've got 2 possibilities, giving us 6 carbons as our longest carbon chain. But if you take a careful look, you will see that they're exactly the same structure. We have, if we were going to number the top one, 1, 2, 3, 4, 5, 6. So carbon number 4 has 2 carbons coming off of it. Or, if we number it the other way, 1, 2, 3, 4, 5, 6, that carbon number 4 still has 2 carbons coming off of it. So it doesn't matter which way we're going to name this. It's going to give us the same combination. Okay, so we've numbered them from 1 to 6 in our longest carbon chain. So 6 is our longest, so our root is hex. And it's an alkane. They all have single bonds, so it is hexane. This is a hexane compound. Now, if we take a look at the side groups, we've got a side group with 1 carbon, another side group with 1 carbon, and another side group with 2 carbons. When this happens, you have to list the side groups alphabetically. So we've got 2 methyl groups and we've got an ethyl group, 2 carbons joined together. So we have to put them alphabetically. So E comes before M. So here's our ethyl, here's our methyls. So E comes before M, so ethyl has to come before methyl. Now, because there's 2 methyl groups, we call it a dimethyl. The di does not change the alphabet. It's still methyl groups. The di just means there's 2 of them. If there's 3, then you have to say 3. Trimethyl. So it's an ethyl, dimethyl, hexane, but we now have to indicate which carbon each side group is attached to. So if we've numbered the carbons here 1 to 6, but if we number them the other direction too, we have to look and see which one will give us the lowest possible number combination. So if we use the red numbering system, we have 2, carbon 2, carbon 3, and carbon 4 used. If we use the blue numbering system, we've got carbon 3, carbon 4, and carbon 5. So we have to use the red numbers because they're going to give us the lowest numbers. So the ethyl group is on carbon number 4, so it is 4-ethyl. And it is 2 and 3 dimethyl. So the 2 and 3 separated by a comma, They both have to be there because they're both on two different carbons. So the whole name is 4-ethyl-2,3-dimethyl-hexane. And this is a structural isomer for an alkane having 10 carbons. 6 plus 2 is 8, plus 2 singles is 10. H22. Drawing alkanes. You can do structural diagrams or line diagrams, or sorry, they're called line structural diagrams. So line structures are basically represent the bonds in the compound, not the atoms. They're really useful for decluttering your diagrams, especially if you've got cyclic compounds. And it's understood that each bend is a saturated carbon. So it contains as many hydrogens as possible. Otherwise, unless it's indicated in the structure that there's a double bond. So what you want to do for a structural diagram or a line diagram is write out the longest carbon chain first. Then what you're going to do is add the bonds. Then you're going to add the side groups. And then the last thing you're going to do is fill in remaining bonds with hydrogens. So 3-methyl-pentane. For the structural diagram or structural formula, you're going to draw the longest carbon chain. So that comes from the root, which is the pent. We know it's an alkane because it ends in ane. So we need to draw 5 carbons connected together. Put in all of the bonds. Each carbon has a max of 4. Then we're going to number them. 1, 2, 3, 4, 5. We're going to put in our side group, which is a methyl, and it's on carbon 3. So you can put it up or down. So here's our CH3 group. It's on the 3rd carbon, so we're done. So now all we have to do is put in our hydrogen atoms. If you're going to do a line diagram, that's 2 carbons. 3 carbons, 4 carbons, 5 carbons. So there's your longest carbon chain. Carbon number 3, 1, 2, 3, has a methyl group. So that's your line diagram and your structural formula for 3-methyl-pentane. As you get more experience, you're going to know that you don't actually have to number each carbon on your structure as you do it. It's just right now so you see where we're adding our side groups. Now 2-methylbutane. Bute is our root. ane tells us an alkane, so we have 4 carbons in a row. Put in our bonds. In carbon number 2, we've got a methyl group, so we could put it here. The rest are hydrogens. So here's 2-methylbutane. We could have also written it counting backwards from the other end. So this carbon would be carbon 2. So if I flip the second structure end to end, it would be identical to the one at the top. So these are not structural isomers. Because I started counting for the other end, it is still 2-methylbutane. So you've got to double check which end gives you the smallest the smallest number combination. Because if I had done 1, 2, 3, 4, just left to right, I would have numbered this 3-methylbutane, which is incorrect. It does not exist. Got to go for the lower of the two numbers. In terms of physical properties, alkanes are nonpolar. They contain nonpolar covalent bonds. Difference in electronegativity is 0.4. Nonpolar. As a result, intermolecular forces are only London dispersion forces, so very weak forces of attraction. So they're not soluble in water, and they have low boiling points. Low boiling points because of these weak forces of attraction, keeping the molecules together to their neighbors. Between carbons 1 and 3, they are gases. Between 4 and 18, they're basically liquids. And if they've got more than 19, they're generally waxy solids. So if you've got less than 3 carbons, you're a gas. So this is because of such a low boiling point. Now the nonpolar means they've got London dispersion forces, so they can't hydrogen bond with water. Therefore, they're not soluble in water, but they can dissolve in nonpolar solvents.